If our captioners are on the line, do you mind typing some tests in just when you're ready so I can see that we're set up to go? Alrighty, so we might not have live captioning on this webinar, but what we'll do in that case is we'll be captioning after the case. So before I waste any more of y'all's time, we can go ahead. Good morning. Welcome to EPA's Computational Toxicology Communities of Practice. My name is Cameron Clark. I'm a Student Services Contractor in NCCT. Today we're going to be hearing from Dr. Colleen Elonen and Dr. Jennifer Olker from EPA's National Health and Environmental Effects Research Laboratory. And they're going to be talking about the ECOTOX Knowledgebase and some new tools and data visualizations. So with that, I will let y'all take over. And if anybody on the line has audio issues or video issues, please feel free to speak up or type something into the chat box. And we'll get to questions at the end of the webinar.
Great, thanks. This is Colleen Elonen. I'm joined here in my office with Jennifer Olker. We both work in Duluth, Minnesota. Jennifer and I are actually dual roles. I am a chemist for the Wetlands and Watershed Functional Indicators Group. So I've been doing the ECOTOX Knowledgebase now for about 4 years as a detail. Jennifer is a postdoc working here on some thyroid and frog testing things, and I'm going to do the first part of the webinar, and then she's going to take over and do some demonstrations for you. Is it okay? Everybody hear me?
Yeah, I think if you're on the line, please make sure that you have your phone muted. I think that's one of our participants.
Okay.
Yeah, my again, I can hear you fine.
Okay, thank you. My concern is just I'm not seeing the Adobe mini box, so if there's any questions, again, put in the chat, and then Cameron can acknowledge that at the end if there's some questions. So I'm going to get started. Again, I've been doing this. I'm Colleen, and I've been doing this about 4 years, been the coordinator of the program. As many of you know, it's been around for about 30 years. When Chris Russum retired, I was asked if I would take this over, and I did so with the help of Carly Elonen, Jennifer, and...
The leader has muted your line. To unmute your line, press #6. The leader has unmuted your line.
Okay.
The leader has muted your line. To unmute your line, press #6.
Y'all still there?
The leader has unmuted your line.
Hi, this is Colleen.
Hey, sorry. I think I tried to mute our participant lines, and I muted y'all as well. So
okay.
We lost your audio there.
Yeah, I'm not sure how to do that if you globally mute, how to unmute. So
I think it'll be hard for us to do with y'all presenting remotely. So we're just going to go as is, and sorry about that. Y'all continue on.
Okay. So again, as I was saying, it's now a team made of myself, Jennifer, Carly Elonen, and Dale Hoff. So we also have 14 contract staff and 2 C employees that work on this knowledge base with us every day. So For those of you that don't know what ECOTOX is, it's a comprehensive knowledge-based system that summarizes toxicological data from single chemical exposure studies to terrestrial and aquatic organisms. We cast a broad net to capture all pertinent literature from sources such as journal articles, gray literature, things such as government documents, theses, or dissertations using a comprehensive strategy. We're continuously reviewing articles for inclusion, and our database is updated quarterly to our public website. We have over a 30-year history, and we're supported by numerous EPA program offices and the Office of Research and Development. Annually, we add approximately 1,800 species and 1,500 chemical results and over 40,000 test result records to our knowledge base. What is the ECOTOX knowledge base? Again, our knowledge base has information on more than 11,000 chemicals and 12,000 species from over 47,000 references. This has led to over 90,000 unique test records in our database. We're available to the public. Each month there are approximately 150,000 data downloads from our users. Queries or searches of the data can be done by chemical, species, or endpoint of interest, and there are many different ways to customize the output to be useful or applicable to the end user's needs. Our application is maintained on EPA servers with JavaScript on the front end, Cold Fusion secondary, and Oracle on the back end. Some of the impetus for the development of the initial database was due to the fact that both researchers and risk assessors had identified a need for a comprehensive, multi-use, one-stop shop, not only to locate high-quality data to prioritize chemicals in chemical cleanups, for example, but also for assessing the hazards of a variety of different pollutants. This data source had to be transparent and provide a systematic review process that was defensible. We have a well-established systematic review and data curation procedure in our pipeline, from the chemical CAS number and synonym verification steps to our literature searches using inclusion and exclusion criteria, and the final application of our applicable, non-applicable criteria before being able to code or enter the test data results into the knowledge base. Each year we receive specific chemical search and encoding requests from program offices and high-level research projects, but we also include any of the chemical test data found in the relevant papers. In 2017, we skimmed over 90,000 references for data that may be applicable for inclusion into our knowledge base. Each month, we also perform searches of 26 relevant journals, with 11 of those being highly relevant, and skim for applicability any recent citations that might meet our criteria for inclusion. Last year, approximately only 2,100 of the 18,000 references that we skimmed met that inclusion for the standards for inclusion. From this initial review of papers, only about 15 to 30% end up being deemed applicable and are fully curated for inclusion. We get many questions regarding our well-established literature search procedure, and this schematic will illustrate some of those procedures for you. Once the chemical or keywords are identified, the search is sent to 6 different search engines. Each of those searches sends citations results, which are then collated and duplicates are removed. In 2017, more than 90,000 references were skimmed, and we downloaded 44,000 potentially applicable references into our back-end unified system, which will then be reviewed for acceptability and fully curated as time permits. To be included into ECOTOX, the reference papers must meet numerous criteria. Studies done with single chemical exposures, chemicals with verifiable CAS numbers, and test reporting controls, for example, are some of the applicability criteria that are applied to the citations. Some of the exclusionary criteria that we apply to citations are if the study was done on humans or monkeys, or if it's a review article, or the full publication is not in English, or things such like that. All of the collated citations are tagged with the keywords for rejection and why they were not included into ECOTOX. This allows us to go back at any time if criteria changes and review those papers for possible inclusion. For example, one of our program office partners now wants in vitro studies coded, or if the requester wants test information, even if no control was reported by the author. The knowledge base has the ability to allow users to refine and filter data searches by 19 parameters, such as species, chemical, or effect, and customize the output selections from over 100 data fields. The main data parameters in ECOTOX that can be searched are highlighted here in the brown boxes, and the blue fields are available as additional output filters that can be applied to give the end user very specific information in the results. Our primary focus this year was to update the knowledge base to be more user-friendly and provide rapid access to critical data. Because of the large amount of test records in the knowledge base, the current website queries could be cumbersome and the 200+ columns of potential result output overwhelming. There's also no real easy way to explore the data in the knowledge base. You had to know what chemical, species, or effect had information coded into ECOTOX to get the search started or to retrieve any of the data results. There was also a defined need across program offices and research projects to increase our interoperability with other databases so that end users had access to a wide wealth of information at the touch of a button, as well as some new applications for the data, such as adverse outcome pathway developments. With our beta development, we realized that not only could we update the ways to access the vast amounts of data test records in the knowledge base, while maintaining the quality and comprehensive that ECOTOX has always provided the end user, but also could improve and enhance utility to our knowledge base to other applications. Growth, mortality, and reproduction were the primary endpoints first encoded into ECOTOX, but over the years, other effects and endpoints have been added. Genomics, early molecular initiating events, and endpoints not directly related to mortality have recently been added as more research is published with these types of information. We'll show you in a few minutes how to explore these endpoints and effects in our demonstration. One of the new features of the knowledge base is the condensed default output format, which includes critical fields here seen highlighted with the blue boxes. But users can customize the output to include all of the data fields which are coded from the publication. Many of you remember the old ECOTOX output with 200+ columns of data, but we have now condensed that down to 25 most relevant fields, but users can click and select any additional data fields of interest. Until June 7th, this is a screenshot of the current ECOTOX website. We've been encouraging all users to try the beta version from the direct link on our homepage. And once all the approvals and communications are completed, this website will be removed and replaced with ECOTOX 5.0. So I'm going to turn the presentation over to Jennifer, and she'll demonstrate some of these new features on the new user interface. All right, so hopefully we have a smooth transition here. Thank you, Colleen. And we'll start with looking at the new ECOTOX user interface. It looks very different. That's to meet the 1 EPA standard also, but also to really get across the important pieces. Along the middle section here, we've highlighted the chemicals that have recently were requested and had the full literature search and data extraction completed information. And then across the top, we've got search, explore, and help buttons. The search button is very similar to what the advanced search used to be and allows you to do quite a bit of the same things with some added features. You can search by chemicals, and one of the things we're excited about is the capability to interact with other tools and databases and have a simple link here out to the chemistry dashboard in case you need to look up a chemical name, get the spelling right, find the CAS number, and then you can return to ECOTOX and type in what you need. You can also search by starting with an effect, with specific effects that you know has been coded into ECOTOX, or start with one of these effect measurement groups. You can also start searching by endpoints if you are just interested in mortality or if you're interested in some other information. And you can search by species, either a species common name or scientific name, or by species groups. I'll walk through one example where we search by a chemical. And here I'm just going to search by a chemical group, and we're going to start with mercury because, as most of you know, there's quite a bit of mercury data in here. And then because there is so much data, I know I won't be able to see it all, so I'm going to limit this to only looking at the LC50s and LD50s. So one of the new features in this search is the ability to see your search criteria along the left-hand side. This may seem really basic to those of you who have never used ECOTOX before, but in version 4.0, which is going to disappear in a few weeks, your search criteria kind of got buried in the tabs, and so you had to remember what you had searched for before you hit the search button. Here it's all documented on the left-hand column. So if we update our search here, then we see that there are 2,384 aquatic records, and this is just displaying the 25 default output fields that Colleen just described. If you wanted to include additional output fields, you can click the Change Display field, and the remaining 170 some are here. And you can select some of the common ones that I end up selecting are gender, especially if I'm looking at reproductive endpoints. I want to know what gender. Perhaps I want to know what pH was tested at and what temperature. But there's a whole variety in here that are coded if it's relevant for that study. You can also see we've got two tabs on the top. One of them is terrestrial data. Currently, the aquatic and terrestrial data are in separate databases because they actually have different fields. And so searching, you have a separate search for terrestrial and aquatic data. So I just flipped back over to the aquatic data, and look at this other green box over here. I can actually then export this data. I didn't choose any extra data fields, so I'll just go those 25 defaults, and I can export it as either an Excel file or a delimited file. Perhaps what I'm most interested in are the references behind these results instead of the actual results. In the top right-hand corner, there's a little box that looks like maybe a recipe box, but it's actually the list of references that are used to provide those results into ECOTOX. You can't see it here, but at the next release in June, there will be a button in here to download that list of results into, I believe it's a CSV file. So when we go back to our results here, other feature I wanted to highlight was this button on the bottom of the left panel. It says View All Applied. So this is how you can keep documentation of what your search criteria were when you complete a search. You can see it all here. That looks almost identical to what you see on the left-hand side, but the difference here is you can export this and get it out as a text file with a time and date stamp so that you know exactly what your search, when your search was done and what you searched for, so that, say, 6 months or a year from now, you can go back and complete the search again with the same search criteria, either looking to see if there are additional records or perhaps you want to go back and add more output fields to your records. So that's the search in a nutshell, and I'm just going to move on to what I'm most excited about, which is the new abilities to explore the data in ECOTOX. Because if you are like me, you know exactly what you want, and you have gone into ECOTOX and you search for it specifically what you want, and either you get no records, which is not very helpful, or you get too many records to download. I think the limit has for many years been 5,000 records. So even if I could download 5,000 records, sorting through 5,000 records is not really an easy task. And so we have developed a set of ways to explore the data in ECOTOX so that you can zoom in and out of the data availability. Now click on Explore. Oh, back to home. Going to Explore. We have 3 different ways we can explore starting points. You can either start by exploring based on chemicals. This is my standard, but for other applications, it might make more sense to start by exploring by species or species group. And you can go back to Explore on the top here, or we can just X out this little button up by the species on the dark blue bar. You can also go in by effects. Searching by effects or exploring by effects is a newer approach for me, but is very relevant in looking for empirical data to develop or support adverse outcome pathways, because usually you're looking at effects more than chemical-specific information. I'm just going to walk through an example of an Explore with chemicals. And so I went into the Explore for chemical, and I'm going to go down here to DDT and metabolites. This is a predefined chemical group. I could also type in a CAS number on this left-hand side under custom group and search for one or more specific chemical. But I'm just going to show the example with DDT and metabolites and explore the data. So this custom group consists of 7 chemicals, including DDT, DDD, and a variety of other related chemicals. There are 2 lines that say DDT because they have different CAS numbers, likely due to a change in CAS numbers over the history that data was input into ECOTOX, and it's actually something that we periodically go through and try to clean up, but oftentimes we can't catch them all in every quarter that the database is updated. So in addition to looking at this list of simple summary of chemicals, we look at the actual records. This predefined chemical group has over 6,000 records in it. And I can see just right away that there's a mosquito and a frog and catfish, and say, oh, actually, maybe I'm really just interested in aquatic data. So I'll go up here and deselect the terrestrial data and limit it just to the aquatic data. So unlike the search, you can actually include both the aquatic and terrestrial data in your Explore at the same time. So now we see that there are 3,833 total records in this set. And we can start to explore it a little bit more detail. So up on the top right-hand corner is the data visualization to help you explore. And here we're looking at the chemical concentration, so the concentration of exposure, that has been standardized to an equivalent of parts per million, if that was possible given the author-reported information. And then the x-axis is the duration of exposure. So this type of visualization is really of interest if you're curious about chronic studies versus acute studies. And we're just going to zoom into this tiny little corner down here where it's shorter term and lower concentrations. And you can see there's actually a lot of data hidden down in that little corner. And the different chemicals that are in this plot are all color and shape coded, and this dark gray square seems to be obscuring everything else, and that is DDT. So I'm actually just going to turn that off and see how much other data there is behind there. There's actually is quite a bit of other data for the other chemicals. It's just obscured by the amount of records for that one specific chemical. So in the figure legend, it's interactive, and you can turn on and off the different chemicals. Another way to view it is looking at the different effects by chemical concentration. So this is the same data, but instead of having the duration of exposure on the x-axis, we have the different effect groups. On the far left is mortality. So as you would expect, that's where most of the data is. But we also have accumulation, growth, behavior, intoxication, development, and on and on. These are the effect groups that have coded data into the ECOTOX Knowledgebase. And on the left-hand side here, there's a variety of on-the-fly filtering options that you can use, and I'm just going to show an example where I go into species group and I specifically select fish. So now it's going to restrict the data showing in the figure, only be that for fish. And in addition to being able to zoom in and out and on-the-fly filter, there's a hover over tool built into this, so you can hover over a point and see what it is, and you can click on it and it'll pull up that record in the table that's below the figure. So in this case, it was exposure of rainbow trout to perthane, and it was a mortality of actually LC50 endpoint in that study. So that's a pretty fast view of the search and explore. And what I wanted to highlight today was an example of how we have started to apply these new features in ECOTOX. In fact, the folks that are here who use ECOTOX data regularly can't go back to the version 4 because we've gotten so accustomed to using the new version. So to show this example of how we've been starting to use these new features,
and the value that there is in the interoperability across different tools and databases, and we're very excited about this. And so I'm just going to show the simple example with a question of what are the effects of pharmaceuticals on aquatic organisms? That's a very general question. So I'm going to restrict it a little bit to say, well, we'll first see what pharmaceuticals are there in environmental samples, and I pulled up a subset of a list of pharmaceuticals that were found in the Great Lakes. Just these 11 pharmaceuticals. We thought what might be interesting to find out what type of empirical data is there for these 11 pharmaceuticals. So, as most of you know, we need a literature review, and that is could be a long, cumbersome process. And so, what I'm going to show you now, that is within a few minutes, we can make huge leaps into that process, because a literature review would include collecting the complete information about each chemical, identifying potential molecular targets, looking for effects at cellular tissue and organismal levels, and then trying to define the species applicability. So we will start with the ECOTOX Knowledgebase, and we're going to start in Explore. So I'm going to start in Explore and go by chemical, because my starting point here is a list of 11 pharmaceuticals, and down in this custom group I just copied and pasted the CAS numbers and use that custom group. And I can see right away, it's a little small because I was trying to get all 11 chemicals to show up on the screen. You can see that all of these 11 pharmaceuticals all have multiple records in ECOTOX from multiple publications. This one here, ranitidine, has the fewest number of publications, but they're fairly recent, from 2009 and 2010. So there's quite a bit of data in ECOTOX as a starting point for the literature review that you might want to do to understand this. I'm just going to focus on one of the chemicals, 17-beta-trembolone here, and really dig into that chemical for exploring in ECOTOX and interacting with other tools and databases. Click the little green arrow, it brings you right into the list of records for trembolone. And there are 660 records, which is a reasonable number to start looking at. And just my first question is, how many species have data for trembolone? And I can click over here. Maybe I can actually click back one. Okay, so here's our table of total records, but I don't like looking at a table so much, so I'm going to first click over onto the figure and look at what types of effects data are available in ECOTOX Knowledgebase. And they're actually quite diverse. It's not just mortality, it's not just reproduction. There's some biochemical data, some hormone data, genetic data, quite a bit. And these data come from 12 different species. Looks like there's a combination of fish and frogs and a nematode. And there's a few others down off the screen that we can't see. So there's definitely some empirical toxicity data for trembolone. So now I'm going to take a step back and go look for some chemistry data, which this is definitely the source that I would use, as I'm sure most of the people on the phone would use. And search specifically for trembolone. And here I can go in the Computational Chemistry dashboard and look at the structure, the physiochemical properties. I can read the Wikipedia entry and learn that it's an androgenic steroid that's primarily used in livestock for muscle growth and appetite. And if I need more information, there's a wealth down here under all these different tabs. The links tab brings you out to a variety of other sources, and we've been working with Anthony Williams to, and sometime in the future, get an ECOTOX link under here as well. That doesn't exist yet, but we're working towards it. So when that does exist, that will bring you back out to the ECOTOX Knowledgebase in the Explore for that chemical. But the information I want to gather, in addition to the physiochemical properties about this chemical, is start to get at the potential molecular targets. So I'm going to go onto the Bioassays tab and click in there, and I can look at the in vitro assay data from ToxCast. This is, again, it's a little small, but we can start to see that there's a bunch of points out here that all appear to be the same color. These are all the assays that have data for trembolone. so assays in which Trenbolone has been tested and have low AC50s that are below the cytotoxic limit. If I look at all these here, most of them are actually nuclear receptors. If I highlight just the nuclear receptors, see all of these here on the left-hand side of that plot. And so I'm going to find out more about what are these targets for these nuclear receptor assays. Let me go down to the table and look at it. It's just a simplified table that I pulled up and sorted by the AC50 from the lowest to the highest concentration so that I can really look at the assays in which Trenbolone seems to be having an effect at the lowest concentration. And if you look at this list, it's not a complete list, but it's just the top of the table, you can see that many of these are androgen receptor assays. So that gives us a starting point for potential molecular targets. And many of these androgen receptor assays are also linked to AOPs that have already been developed. There's two AOPs that it's linked to, one that is in mammals and one that is in fish. To think back to my first question, I was thinking about aquatic organisms. So I'm really going to focus on this AOP that was androgen receptor agonism leading to reproductive dysfunction in repeat spawning fish. So if I go into the AOP wiki and look at that AOP, you can see it's been around for a while because it has a fairly low number. AOPs, I think it just gets numbered chronologically as they get added. And there are a variety, lots of information in the AOP wiki that I'm not even going to cover here. But if we look specifically at the list of key events, we can see that androgen receptor agonism leads to reduction in 17-beta estradiol, a reduction in vitellogenin, and a reduction in cumulative fecundity and spawning. So that moves us from looking at a potential molecular target to thinking about the potential effects at the biochemical, cellular, tissue, and organismal levels. And then from there, we also want to understand what species this was developed for, and the taxonomic applicability information in the AOP wiki shows that this was developed for the fathead minnow. So we're going to go back to the ECOTOX Knowledgebase now and search for empirical data for effects of Trenbolone on fish. I'm going to pause for a minute. I'm not sure where that echo's coming from.
If any of our participants are participating both through the phone line and through the webinar, make sure you mute the computer speaker. All right. Hopefully somebody either dropped off the phone line or muted their speaker. Are y'all doing okay now? I think our feedback stopped.
Yep, it sounds good now. All right. So we had just gotten through looking at the AOP wiki information and going back to ECOTOX Knowledgebase to search for empirical data for effects of Trenbolone on fish that either support that AOP and possibly expand the species applicability. So this is going back to what I had pulled up before for Trenbolone in the Explorer of the ECOTOX Knowledgebase. And now we know that we really want to specifically look at specific species group. We're going to change that to fish, and also going to change it to a specific endpoint. So here I changed it to fish in the species group and looking at the lowest observed effect concentration as the endpoint. Still, there's quite a bit of information encoded into the knowledge base that we can look at. And I'm just going to zoom in down on this bottom. And so I can see those lowest concentrations for which we have empirical data. And I'm again going to use the hover over tool to see the second column here. These are genetics. So I'm going to click on genetics. You can see that is at 0.00000106 parts per million for a fish that I had never heard of before, but I had to go look up. The viviparous blenny. So there is some, so then if I click on that point, I can pull up the table information and see that in this record, it's actually a reduction in the estrogen mRNA after exposure to Trenbolone. So that provides some support, and in a different fish species for genetic effect. If I then go over to biochemistry, and the biochemistry effects group, okay, I'm getting a little bit of an echo again.
Sorry. I'm going to have y'all click *5 on your line, and it's going to mute me as well. And when you finish presenting, hit #5, and it'll unmute all of us.
Okay, *5?
Yes, ma'am.
Okay, here we go. Can you still hear me okay?
I can. Hopefully you can't hear me.
I actually can hear you, so well, I don't know if that did anything.
All right, well, let's just ride it out. Again, to our participants, if you're participating with the audio through your computer, you can't call in at the same time, so you have to choose one of those two audio options.
All right, it sounds like it's gone again, so I'll just move on. We're going to look at the biochemistry results in ECOTOX, and we're looking at this lowest point here. It is exposure in a zebrafish, and if I click on it, I can see that this was a change in the vitellogenin after exposure to trembolone. Again, that provides support from a different fish species for that same AOP. And then if I move over to the reproduction column, in a reproduction effect group, and look at that, we can see that is in the fathead minnow, which is what the AOP was developed for, and it's actually a reduction in fecundity, providing additional support for that AOP. So what I was attempting to show here, with a few pauses for some echoing, was a pretty fast way to go from a general question linking through the chemistry dashboard and the AOP and then into the ECOTOX knowledge base to get in vitro data, chemical data, and in vivo empirical data all on the same question with very, very little effort, very rapid. Of course, for any of these, you'd want to dig in a little bit deeper to better understand the in vitro assays, better understanding the results that are reported in the ECOTOX knowledge base. You probably would want to look at the gender and the life stage and the exposure duration from those specific records. But that's all encoded within the knowledge base. So that's pretty fast tour of the changes to the ECOTOX knowledge base. If you are interested in knowing more about the procedures that Colleen described that have been in development for many years, they are all included on the help web page. And if you're interested in walking through any examples, they are included in the user guides, so you don't have to try to remember what I clicked and where. But we had an exciting meeting yesterday in preparation for our June 7th release of ECOTOX Knowledgebase version 5. And there have actually been changes added over the last few months based on the beta testing and training that we've done. We were able to incorporate some user suggestions. And I just want to highlight a few of those before we move on because I think they're very exciting. So if I go back to the home page, this is where we started before. So for now you can see that these recent chemicals that were requested by a program office or a research program, they all are hyperlinks that will actually take you in to the coded data for that chemical. I'm going to just show the example of the dichloroprop P, which was requested by one of our cooperating program offices. If I click into there, we go directly into Explore for that chemical. So you'll notice right away that this is not one chemical. This is actually a list of multiple chemicals, which really highlights the fact that when we have a chemical requested, the chemical verification process includes synonyms, degradatives, related compounds. So you get just not one chemical, but you get a suite of chemicals that are all related that go into that literature search. And you can see, so there's a whole suite of chemicals. I can't remember how many there are. Oh, there's 16 chemicals. So one of the other things that we've added is some additional options for filtering. As you'll see here, there are actually 200 species that have results in the ECOTOX knowledge base for dichloroprop P. if I was going to go through this list of species, it might be a little challenging to pick out those that are I was actually interested in. And so up here, for a long time, we've had this species group, 15 species group. 15 different species groups are represented here, but sometimes you want some resolution in between the species group and the specific species. And so we've added the ability to filter on family and genus, which is really handy, especially if you're looking at terrestrial data for insects where there are many different species within a genus that you might be interested in, and you can just select that one genus. Additionally, in the optional output that we described previously, we have included the NCBI taxa ID that you can select to include in your output. So then if I go into I'm sorry, I'm just going to show you the families here. So, and then the genus option. I was excited to move forward to showing you the changes we made to the interactive plots. So this example, you can see there's a lot of dots along the bottom because there are two records that have really high exposure concentrations. So this is an example where it would be challenging to zoom in on this bottom section really smoothly with the current plot zooming option. So we've added on the bottom a concentration filter, so you can see the range of the concentrations that are included on plot, and then filter them down here instead of zooming on the plot. And so if I filter this down to 1,000 parts per million, you can start to see some of the data points be revealed that were all hidden on the x-axis. And if I filter it down even further, down to 10 parts per million, you can really see there's a lot of data that's on those really low concentrations that otherwise was obscured by the range on the y-axis. And this can just be reset in the same way that you would reset a zoom on the plot. So it might be interesting to find out what these 2 points are because they seem to be really outliers in the exposure concentrations. So this one up here is actually a record from quite a while ago with some carp, LC50. That's a fairly old paper if I recall correctly. And this one here is a chemical that I don't know much about that ended up as part of this group of chemicals from this request, and a species that I don't know a whole lot about, but it's an effective concentration for 50%. So if I then look at the table down below this, some of the other things we have added and hope to add. So currently we have added this blue one that's highlighted as the record associated with that point. You have the reference here. We have added the ability you can hover over and see the full reference. And we would love, and we're working towards developing a method where you could then take this record and send it to Google Scholar so that if you had access to that journal, you would be able to look at it right away. That's not in place yet, but it's in the future. And then another future feature that we're hoping to add, actually probably in the near future, the ability to hover over the CAS number in any of these tables, summaries, get the full name again so you can see it a little easier, and then be able to link out to chemistry data in the chemistry dashboard. This again is not in place yet, but it's the direction we're heading to try and increase that interoperability and user ease to get all the information as quick as possible. So these last few slides have really come out of the most recent training and testing, and we are continually looking for feedback and encourage people to go out and use the beta between now and its next release in June 7th, and then after that even. And we are collecting information. If you have questions, if you have comments, if you have suggestions, filling out this contact us section or calling these numbers and emails, it goes to us, it goes to Colleen, it goes to the support staff, and you typically get a response back very quickly. That's really a pretty quick view of everything, and we would be happy to take any questions.
Yeah, thank you all so much. So I think we already got a question on the chat box. I'll go ahead and read that out. But anyone else, feel free to speak speak up on the phone line or type your question in the chat box as well. So the first one is, thank you for the very helpful presentation. Any possibility that the ECOTOX tool can now be used to generate species sensitivity distributions? It would probably be tricky to get it to work, but still, would this output be possible?
So it depends on what method, if you're trying to actually do some additional calculations for your species sensitivity distributions. We are, the ECOTOX Knowledgebase is used for so many different applications that we have not moved into the next step of adding specific question interpretations and summaries, although that has been requested. The one thing that we have been thinking about is how to help make it really clear what the how the effects information that are in ECOTOX relates to field measurement of environmental contaminants. And so we've been thinking about how to add a user-defined line or multiple lines that show the levels that have been measured in an actual environmental sample.
Yeah, we do get the species sensitivity distribution question quite a bit. And again, as Jennifer said, because it's such a broad-based knowledge base, we feel like it would be a disservice to be able to just do kind of a one-stop blanket overall. But you're able to we're hoping to put in some lines in the future of this could be the most relevant, or everything less than this is the most relevant. And Jennifer has a few examples of that, but she didn't get into it today. But certainly something that you're not the first person, Sergio, to ask that question. We get it quite a bit, and we're just trying to kind of figure out how we could do that without doing a disservice to everybody else. So.
Okay, thank you all. Looks like we have another question. This is one I think y'all touched on some, so maybe Mark can clarify if he had a specific aspect of the chemistry dashboard he's curious about, but he said, is the knowledge base connected with the chemistry dashboard?
So I'll answer that general question, and if there's a follow-up, we'll be happy to go into more detail. So currently, from the knowledge base, we have just a general link out to the chemistry dashboard, just so you don't have to go find it somewhere else. The general link, so you can go and search your chemical. We are also working towards having direct connections based on CAS numbers going both directions, so from the chemistry dashboard to the ECOTOX knowledge base, and the other way, from the ECOTOX knowledge base back to the chemistry dashboard. Those are currently not in place, but we've been working on it for several months and hope that we'll be there soon.
All right, looks like you answered that one. Thank you all. Any other questions on the phone line, in the chat box? Alrighty, well, I don't see any. If you do have any follow-up questions, feel free to reply to the meeting invite, and we will pass those along. But I want to thank Colleen and Jennifer so much for presenting, and thank you for bearing with some of our technical issues, all of y'all. So with that, I'll let everybody go.
Okay, thanks. Please use the database. Let us know if you have any questions, either direct email or, like you said, through your contacts, communities of practice. We take any questions. Thanks.
Thank you all.
Thank you.
Have a good one.